All right, guys, we're here with lesson 5 in module 4. We're continuing our work on area, and we're moving in the direction of using multiplication to find area. Now, the benefit of having me as your teacher is that I already previewed that for you because, as you guys know, I do not like to, if I know if I know where we're going, I think it's important that you know where we're going. Like, I don't like to hide that and keep that a secret. So, like, um, if the purpose of this module is to get you multiplying side lengths to find area, then I don't see the point of necessarily waiting 5 lessons in for that. I want you guys to know ahead of time that that's where we're going. Now, it's important to do all the preparation and develop an understanding of why it works. I would never diminish that, but we've already sort of done an introduction to this lesson. So lesson 5 support is supposed to sort of be like new information to you, but we've been talking about it for a few lessons. So we're a little bit ahead of the game, and that should make today's lesson go pretty smoothly for you, I hope. All right, here we go. Again, like I have in the last 2 lessons, I just brought the problem set home. We're going to work right from that. Now, I know you've already done this, but it's good to watch it again to make sure you can understand why it is that things work the way that they do. So these are square centimeter tiles. I have a ruler here with me, which I will use when needed. This first one I don't. It says, I have 3 centimeters here, which you can see I have 1, 2, 3, right? You see the 3 centimeters there. To find out how many are along the top, the 3 is also right there. Like, so we took the 3 centimeters and we put it right there. I have 1, 2, 3, 4, 5, 6. 6 centimeters. Notice, just because I had already counted that one as a 3, like along the left edge there, the top left corner, I still have to measure this one here. Like right there to there is different from right here to here. So from that corner, you can go down or you can go right, and they're 2 different measurements. So even though I've already used it once, used something from this section once, I still have to use it again when I'm going along the top. So 1, 2, 3, 4, 5, 6. So 6 centimeters. So I'm gonna draw another arrow in here and show you where that 6 comes from. Right? They then counted by 3s: 3, 6, 9, 12, 15, 18. I would just say 3 times 6 is 18. I don't love that there's not a measurement on this. I would say square or unit, square centimeters. You can abbreviate square as SQ. So you can write SQ period space CM. Now, the next one says there's an area of 20. I'm going to fill this in, 24 square centimeters. They already told us that part, right? Right. And so now we need to figure out, we have 3 rows. One way you could solve this problem, and if you're ready for this, fine, go with this. You don't have to draw stuff in. You could say what times 3? 3 times some number is 24. What's that number? Right? That must be how many are in each row. So if you have that conceptual understanding of multiplication already, then by all means, I don't care if you draw these in, right? If it's more difficult for you to answer that question, if you're not quite sure, then do this. Say 1 centimeter, 2, 3, 4, 5, 6, 7, and 8. And then go down to the bottom and do the same thing. 2, 3, 4, 5, 6, 7, and the last one being the 8. And then just connect your dots. Oh, some of these aren't very straight. I didn't measure very accurately, I don't think. But still, we'll get the point. We're all done. All right. So then you can see you have 3 rows of 1, 2, 3, 4, 5, 6, 7, 8. 3 rows of 8. And so you can fill that in. Say 3 times 8 is 24 square centimeters. But again, if you are a kid that can look at that problem and say 3 times some number is 24, and the only number that makes that sentence true is 8, you already know that that's 8. So I guess there's sort of 3 levels of understanding here. There's that level. There's the level where you could just put a ruler on here and say it's 8 centimeters. And so there we go. It's 3 times 8. Like I can measure this as 3 centimeters. I can measure the top as 8 centimeters, remembering that the copier doesn't do a great job. So we have to round to the nearest centimeter. Or A third level of sort of understanding is that you might need to draw all these in and actually count the number of squares in each row. And each of those levels is fine. It's fine if you have a different level of understanding than the person sitting next to you in class. Use whatever strategy works best for you. All right, the next one says 4 centimeters times 5 centimeters. So that means that there's going to be 4 rows with 5 in each row. Now, I'm going to, for this one, draw them in, but for the next couple, I'm not going to. So I'm going to show sort of all 3 levels of understanding. So for this first one, I'm going to say I have 5 centimeters along the top. So 1, 2, 3, 4, and 5. And then again, I have to do that same process on the bottom here. And on the right, I have 4 centimeters going down here. 1, 2, 3, and 4. And then I have to connect my dots. Whoops, I didn't draw that one correctly, but you'll still get the point at the end. And so that first sort of level understanding is that I have 4 going down, like 1, 2, 3, 4. And I have 5 going this way. 1, 2, 3, 4, 5. 4 centimeters times 5 centimeters is 20 square centimeters. And I can put my answer at the top as well, 20 square centimeters. So as you can see, I go starting at this top corner, I can go down 4 centimeters to the bottom. And starting at that top left corner, I can go 5 centimeters across to the right. And 4 times 5 is 20 square centimeters. Now, on the next one, it's flipped. It's the turnaround fact. So it's 5 centimeters times 4 centimeters. But this time I'm not going to draw all of them in. So I already know that this is 5. They've already labeled that for me. I'm going to look here and round to the nearest centimeter. And it's, as you can see, it's about 4. Again, our copier made it a little smaller. So I'm going to say that this is 5 centimeters times 4 centimeters is 20 square centimeters. Yeah, that was a lot quicker, right? The ability for me just to measure the top and say, oh, well, I would have drawn 4 boxes along each of those because there's 4 centimeters there. I can just multiply 4 times 5 without drawing them in. You're welcome to do that as well. So that's the second level of understanding. And then the third level that we have of understanding here is that I have 6 centimeters as one side, and I'm given a total of 18 square centimeters. And I think to myself, I don't even need my ruler. I throw that aside and I say 6 times some number is 18, or you could think of it as 18 divided by 6 as some number. That has to be 3. The only number that can go in there to make that true is 3 centimeters. 6 centimeters times 3 centimeters is 18 square centimeters, right? And then you could label that. I know you probably can't see that on my screen, but you can label that down here, right? And that's because you know that this sort of goes back to like module 3 we could have filled in a variable there and found out what the variable was, either using multiplication and that missing number or division. And I'll do the last one the same. I guess I can't do the last one the same way because I don't know the total, but I do know it's 3 centimeters times 3 centimeters. And again, I could fill this in if I need to, and it would look basically, that's a terrible drawing, but it would look basically like that. And 3 centimeters times 3 centimeters is 9 square centimeters. Now you might know just by saying 3 times 3, or you might be a kid that has to say 1, 2, 3, 4, 5, 6, 7, 8, 9, or 3, 6, 9. There's multiple ways to solve these problems, right? From group counting to multiplication, and a couple of steps in between. All right, now we have some word problems. This probably isn't a shock to you that eventually we take our work that we're doing and turn it into word problems. So Lindsay makes a rectangle with 35 square inch tiles. So basically she uses 35 of these, or of those, right? It's probably easier for you to see there. 35 of those, and she has 5 equal rows. What are the side lengths of her rectangle? Use words, pictures, and numbers to support your answer. I would draw a basic picture. I wouldn't draw it to scale. So obviously I'm not drawing like 7 inches by 5 inches here, but I would say 5 inches. I'd say total equals 35 square inches. And then I'm finding the missing piece. What time, I'd say 5 times some number equals 35 square inches. I'm basically replicating what we had on the front side, right? And I'd say the only thing that can go in there is 7 inches. So I have a picture, I have a number sentence, and I need to have some words, right? So I'd say Lindsay has 5 equal rows of 7-inch tiles to make or to cover 35 square inches. So I use that same strategy that we had on the front, drew a picture. I didn't fill in the grid. I didn't feel that I needed to because I knew that I was just going to multiply those two side lengths. Showed what the missing piece was and then solved for it. After I solved for it, I wrote a sentence to explain what I did. So that's sort of the process you need to go through. Don't take shortcuts, right? It says words, pictures, and numbers. So make sure you have words, pictures, and numbers. The next one says, here, whoops, almost knocked my camera over there. These cameras are great until they get wobbly. Mark has a total of 24 square inch tiles. Total 24 square inches. He uses 18 square inch tiles to build one rectangular array. He uses the remainder to build a second rectangular array. Draw 2 arrays that Mark might have made. So 18, so he uses 18 square inches. That's subtraction, right? Because you had this many, 24. You're using 18 of them for something, and then you're going to have some left over. So that's 6 square inches. That's how many you have left over. Write something like that on your paper so you know what that means, right? Understand that you have a total, that you're using some, and this is how many you have left over. And then don't forget the most important part, right? There's 2 other parts of this problem. Draw 2 arrays and then write multiplication sentences for them. So one array might be I have 6 square inches, so 2, 3, 4. I'd write 1 inch times 6 inch equals 6 square inches. Label your work. It's not correct if it's not labeled. This looks a little, let's see if I can zoom. There we go. Is that a little neater? I could also do, whoops, I didn't draw that centered, but 3 inches times 2 inches equals 6 square inches. These are 2 different arrays with multiplication sentences that show how he could use the leftover tiles. There are a lot of words in this problem to do something relatively simple, something that you guys are capable of doing for sure. Read the problem a couple of times. Make sure you understand everything that it's asking you to do. We have people in our class a lot that are getting in habits of not reading the whole question or of doing the first question they ask. Maybe there are 3 sections to their question, doing the first piece and then not doing the second and third. Get in good habits. Read all the way through the problem. Check off things as you do them, like draw 2 arrays, check. Write 2 multiplication sentences, check. Right? Do all those things to help yourself stay on track and make sure you complete your work accurately and completely. It says Leon makes a rectangle with 32 square centimeter tiles. There are 4 equal rows of tiles. How many tiles are in each row? Use words, pictures, and numbers to support your answer. So I'm going to start with a multiplication sentence because in my brain that works. That's what works the best. I have 32 square inches equals 4 inches, because I know that there's 4 equal rows, times some number. That number, the only thing that could go in there is 8 inches, because 8 times 4 is 32. The only number that makes this number sentence true is 8, so that has to be my answer. Then I might draw a picture and say 4 by 8, and then in the middle I might even say 32 square inches. But that just shows if I multiply 4 inches times 8 inches, I get 32 square inches. And then I'd write a sentence. Oyan has 8 tiles in each row because 4 times 8 equals 32. This is a very complete answer. I have used numbers, I've used words, and I've used a picture, just like the question asked me to. And I've answered all the parts of that question. And the bottom says, can Leon arrange his 32 square centimeters into 6 equal rows? Explain your answer. So this one you just have to explain, so you can use words, but I'm going to use numbers also to help. So I'm going to say 6 times some number equals 32. Is there a number that I could put in there to make that true? All right, let's think. 6 times 4 is 24. 6 times 5 is 30. Ooh, that's close, but it's not 32. 6 times 6 is 36. Ooh, I went from 30 to 36. I never stopped at 32. So no, because no whole number can be multiplied by 6 to get 32, right? You can get 30, you can get 36, you get 24, get 42, but you can't get 32. And that's how you would solve a problem like that. All right, guys, you know you're doing awesome. I'm really proud and impressed with all the work that you're doing with area, and especially now that we're using our multiplication division skills to help us solve problems involving area. So keep up the good work and always ask questions if you have them.